Welcome. This video is on prime factorization and factors. Prime factorization is the process of rewriting a composite number as a product of prime numbers. Remember, a prime number is a number that only has two factors, 1 and itself. Like the number 12. 12 is not a prime number, it's a composite number. And its prime factorization is 2 times 2 times 3. The number 2 and 3, those are prime numbers. 42 is 2 times 3 times 7. The numbers 2, 3, and 7 are prime numbers because nothing divides evenly into those numbers except for 1 and itself. The only number that divides evenly into 7 is 1 and 7. It's therefore a prime number. The numbers 12 and 42 are composite numbers. The product of prime factorization must equal the composite number. So if you multiply 2 times 2 times 3, you have to get the original composite number that we started with, 12. 2 times 2 is 4. 4 times 3 is 12. 2 times 3 is 6. 6 times 7 is 42. This is called the prime factorization. This process of learning the prime factorization is important for other topics that we'll discuss later, such as greatest common factor and lowest common multiple or least common multiple. The least common multiple is going to be used for adding fractions. So this is just the beginning of a process that we're going to use for adding fractions. Okay, determining the prime factorization of a composite number. So how are we going to get this 2 times 2 times 3? And there are a couple of different methods for obtaining the prime factorization, and either method is fine. So I'm going to show you both, and then you could choose which method you prefer. And this is called the tree method for prime factorization. And here's a number that we're starting with, 40, just for an example. Okay. Find two factors whose product is the original number, except for 1 in itself. So we just don't want to use 1 and 40 here. What we're going to do is draw two branches under the original number and write each factor under each branch. Okay, so just think of any two numbers. Here's our branch. Think of any two numbers that multiply to be 40. And we'll do this a couple different ways. Maybe you might think of two different numbers. How about 4 times 10? Let's start with 4 and 10. So underneath one branch, put 4. Underneath the other branch, put 10. Okay, now we're going to continue this process until the numbers below each branch is a prime number. So look at this number 4. Is that a prime number? Can you break it down? Are there two numbers that multiply to be 4? Yeah, there's two numbers that multiply to be 4. So we'll put a branch underneath that 4. How about the 10? Right, that's not a prime number either. It's a composite number. So we'll put a little tree underneath the 10 and come up with two numbers that multiply to be 4 without using 1 in itself, and two numbers that multiply to be 10 without using 1 and 10. So for 4 we could use 2 times 2. And for 10, yeah, there's only 2 times 5. That gives us our prime factorization. You write down each prime number at the end of each branch. So we have how many 2's? 1, 2, 3. So 3 2's with a multiplication symbol in between, and 1 5. We do not use the 4 or the 10 because they weren't prime numbers. So we only want to write down the prime numbers and the number of prime numbers that there were there. So 3 2's and 1 5. If you wish, you could also write it in exponential notation. There's 3 2's, so that's the same as 2 to the third. It really doesn't matter unless the directions said specifically to write the answer in exponential form. Otherwise, either one's fine. Let's try it again, this time with two different numbers. How about 5 and 8? Maybe some of you thought 5 and 8. 5 multiplied by 8 gives 40. Okay, so is 5 a prime number? Yes, it is. So we don't need to branch 5. We don't need to place a tree underneath the 5. Is 8 a prime number? Can you break it down? Yes, you can. To 2 times 4. How about 2? 2 is a prime number. Is 4 a prime number? No, it's not. So we'll branch that out again. That's 2 times 2. Again, writing only the prime numbers that we end at. We're not going to write down the 4 or the 8 because they're not prime numbers. Only the 2's and the 5. How many 2's? 1, 2, 3. 3 2's and a 5. The same answer. So it doesn't matter which numbers you start with, the result will still be the same. Okay, don't forget, if at any time you want to take your time and write these down in your notes, just pause the tape. Tape's not a tape. Pause the video and go ahead and push back on play when you're ready to get started. Okay, here's another example. Find the prime factorization of 60. We'll do it twice, once again. So 60. 6 times 10. Is 6 a prime number? No, so we'll branch that out again. And is 10 a prime number? No, so we'll branch that out again. What multiplies to be 6? Right, 2 and 3. And what multiplies to be 10? Yeah, 2 and 5. Maybe you thought of two different numbers. How about 5 and 12? 5 times 12 is 60. Is 5 prime? Yes. 12? No. So we could use two factors to multiply to be 12. You could either use 3 and 4 or 2 and 6. I use 2 and 6 here. 2 is prime, but 6 is not. That's 2 times 3. Okay, so either one. How many 2's are we going to write down? 2 and 3's. 1 and 5's. 1. We're not going to write down 6. We're not going to write down 10 or 12 because they're not prime numbers. So the prime factorization of 60 is 2 times 2 times 3 times 5. Okay, let's do another example. Find the prime factorization of 294. That looks like a good one. Okay, so you might be thinking, I don't know what multiplied by another number is 294. You don't have, maybe it's 18 times 16. I don't know. You don't have to find some two numbers that multiply to be that number. You just have to find any product that will multiply to be 294. Just any product. Now, divisibility rules are important. It ends in a 4. So what does that tell us? That tells us that we could start with a number 2. 2 will divide evenly into any number that ends in an even digit. Any number that ends in a 0, 2, 4, 6, or 8. 2 will divide evenly into it. Now, how many times Does 2 go into 294? Well, I don't know on the top of my head, so I just need to perform the division. So divide 2 into 294. Again, you might want to pause and then work that division problem out on your own. And then hit play when you're ready to get started. Okay, so performing that division, that gives us 147. So 147 is going to go at the end of the other branch. Okay, now continuing. Is 2 a prime number? Yes. Is 147 a prime number? Not sure. So we'll start thinking about what number goes into it. Does 2 go into 147? No, because it ends in an odd digit. It ends in a 7. How about 3? Does 3 go into 147? It does. And you may remember the divisibility test. 1 plus 4 plus 7. If you add the digits, and if 3 goes into that number, then 3 will go into our given number. So 1 plus 4 plus 7 is 12. Does 3 go into 12? Yes. Therefore, 3 will divide evenly into this number. So we could put 3 at the end of the branch. Now again, how many times does 3 go into 147? I don't know at the top of my head. So what am I going to do? Divide. So divide 3 into 147. Again, you might want to pause and work that out on your own. Okay, 49. So we could put 49 at the end of the other branch. 3 is a prime number. Is 49? No, that's not a prime number. That is 7 times 7. So this was a large number to start with, but using our divisibility test and knowing how to divide, we were able to get the job done. So the prime factorization is 2 times 3 times 7 times 7. Okay, let's go to the next example. There is another method called the division method. Divide the given number by the smallest prime number that divides evenly into the number. Then, directly above, divide the result, or your answer, by the smallest prime number that divides evenly into that number. Continue this process until you have an answer, which is a prime number. The product of all the prime numbers is the prime factorization. You might want to take a minute to write that down. Again, continually pause the video and then click back on play when you're ready to get started with the example. Okay, find the prime factorization of 315 using the division method. So we write down the 315 inside a division box. Now we're going to put the smallest, it says divide by the smallest prime number that divides evenly into the number. So the smallest prime number is 2, but does 2 divide into 315? No, it doesn't, because it ends in an odd number. The next prime number is 3. Does 3 divide evenly into 315? Yes, because if you add 3, 1, and 5, that adds to 9, and 3 divides evenly into 9. So 3 will divide evenly into this number. Now you might want to do that division on the side, but your answer just put above this division box. So go ahead and divide, and you should get 105. Okay. Now we're going to continue this process we're going to divide the result by the smallest prime number that divides evenly into that number. So again, 2 doesn't go into this 105. Does 3 go into it? So put another division box. Yeah, 1, 0, and 5 is 6, so we could put a 3 in front again, and then divide 3 into 105. That gives us 35. And now we're going to divide that number by the next smallest prime number. Does 3, we can keep using 3 over and over if it keeps dividing into our given number. Does 3 go into 35? 3 plus 5 is 8. 3 doesn't go into 8. No, 3 will not go into 35 evenly. What's the next prime number? 5. Does 5 divide evenly into 35? It sure does. Any number that ends in a 0 or a 5, 5 will divide evenly into that number. So we'll put a 5 in front. Now, how many times does 5 go into 35? 7. So you can put a 7 above. Now, once this number at the top is prime number, we are all done. All these prime numbers here going up vertically, that's our answer. That's our prime factorization. So there's 2 3s, a 5, and a 7. And you can multiply it to double check. 3 times 3 is 9. 9 times 5 is 45. And then 45 times 7 should be 315. You always want to check it, especially during an exam. It's easy to make a mistake. We all make mistakes. So take your time. You might want to make sure that that product is your given number, 315. Okay, let's do another one, 150. And try to use the division method. And after you do a couple, then you can decide, hey, you know what? I want to do the tree method. Or I want to do the division method. And either method is fine. Okay, 150. Does 2, let's start with our smallest prime number. Does 2 divide evenly into 150? Yes, because it ends with a 0. So we'll start with 2. 2 into 150 is 75. Okay, now we'll divide it again by our prime number. Does 2 go into 75? No, because it ends in a 5. How about 3? That's the next prime number. Seven plus 5 is 12. 3 goes into 12, so 3 will go into that number. Yes, so we could put a 3 in front, and then divide 3 into 75. 25. And now we'll divide 25. That's still not a prime number. What goes into 25? Well, not 3, but 5. So divide it by 5. 5 times 5 is 25. And our top number is a prime number, so we are all done with this problem. A 2, a 3, and 2 5s. A 2, a 3, and 2 5s. And just put a multiplication dot between each one. Multiplication symbol. Okay, let's talk about factors. We were talking earlier about prime factors. 3 and 4, 3 times 4 equals 12. They're called factors, and the result 12 is called the product. Now, there's other factors of 12. There's 2 times 6, and 1 and 12 are also factors. So this is a complete list of factors for 12. 1, 2, 3, 4, 6, and 12. These are all the factors. Some of these are prime. Let's see. 2 is prime. 3 is prime. 1 is not a prime number. The smallest prime number is 2. A prime number has to have 2 distinct factors. That means 2 different factors. And the only way to get 1 is 1 times 1, and they're not different numbers. So 1 is just not considered a prime number. The smallest prime number is 2. So we have 2 and 3 are prime numbers here. 4, 6, and 12 are composite numbers. 1 is considered neither prime nor composite. Okay, another way of stating what a factor is, they're numbers that divide evenly into a given number. So we could also say that 1, 2, 3, 4, 6, and 12 all divide evenly into 12. There's no remainder if you divide 12 by 2, or 3, or 4. The number 5 is not a factor because it does not divide evenly into 12. You would get a remainder. Okay, list all the factors of 24. Okay, so what we could do is check sequentially the numbers 1, 2, 3, etc. to see if we can form any factorizations, any products. So let's write down that number 24. Now, let's start with 1. Does 1 go into 24? Yes. So it's 1 times 24. Those are 2 of our factors. Let's keep going. Let's try 2. 2 times what number is 24? 12. 3. 3 times what number is 24? 3 times 8. And then there's 4 times 6. How about 5? No, 5 doesn't go evenly to 24. The next number would be 6, but we already have 6 on our list. So once you start seeing this number on our list, then you're all done. You're just going to get the same numbers on the other side of the column. So try to go in order. You don't want to miss any points on a test because you missed one of these pairs. That's why it's just best to start with 1 and keep increasing until you get the same number on the other side. So these are our answers. 1, 2, 3, 4. And just write them in commas. We're not writing the prime factorization, so there's not a multiplication symbol in between. Just a comma between each number. So 1, 2, 3, 4, 6, 8, 12, and 24. Alright, let's do one more. List all the factors of 60. Again, let's start with 1 and then 2 and 3 and see if we can form any factorizations, any products. So we start with 60. There's 1 times 60. Again, you might want to pause and work on it and then click on play when you're ready to see the answer. Okay, let's see. What's the next one? 2 times 30. You might want to, if you can't do that in your head, then do the division on the side on your scratch work. 3 times 20. 4. Does 4 go into 60? Yes, it does. 4 times 15. 5 times 12. 6. Yes, 6 times 10. 7? No. 8? No. 9? No. 10? Yes. But then we're on the other side of the column. So we're all done now. We're just going to list our answer. And then we're all done there. Make sure we got all of them down. And that is the answer to listing all the factors of a given number. Okay, that's the end of this lesson. I'll see you here for the next one.